Hello everyone and welcome to the video edition of the AI GI Actuary, which I presented at the General Insurance Seminar on the 13th of November. This is for all the people who missed the presentation. I hope you guys enjoy it. So by way of introduction, who am I? I'm currently the head of Actuarial and Analytics at World Nomads Group, soon to be rebranded NIB Travel. Data Analytics Working Group member, or YDOG, and my prior experience spreads a bit across reserving, pricing, portfolio management, and data analytics. And helping me out with some of the content is my good friend Michael Giadlo. He's currently Senior Manager, Strategy at Commonwealth Bank. And his experience includes model risk management, policies, and frameworks. So who are you? If you are attending the GI seminar, you would be and the actuary in charge of select all that apply. It's now the afternoon session of the second day. You're probably feeling a bit sleepy, and but you're kind of curious about AI and what it can do for you, or what it can do for society, or maybe you're a bit worried that at all the things that are in the media, perhaps AI is far more dangerous than nukes by Elon Musk. Facebook shuts down robots after they invent their own language. The Telegraph UK. We got Stephen Hawking saying that the rise of AI could be the worst or the best thing that has happened to humanity. And then you have like an actual YouTube channel with 2.6 million views talking about how the guys invented an AI that extracts the psychic parts of everyone. You're thinking, what? Seriously? Really? And that's a bit of, well, mostly all hype. Let's talk about what AI can really do for you. So, in terms of this presentation, we're going to be on the more business side oriented side of things compared to where I usually talk to. We've also got the paper that is available on the microsite for this, and that's a bit more technical, going into a bit more detail. And we've also got the analytic snippets, which is a column that I've been managing with some guest writers. We do some practical examples working through machine learning, data analytics in R and Python. And if you really want to get into detail, there's many great papers and courses out there, such as the Google TensorFlow course, or some of the ones by Coursera. There's many options out there if you want to get into the detail. So what is AI? The Oxford Dictionary presents the following definition. It's the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. But what does that mean in practice? Historically, we've used expert rule systems. Sometimes you'll see that AI is actually just rebranded traditional statistics. You may find the use of machine learning models, such as decision trees, and deep learning, which we'll talk about just a little bit in this presentation. And ultimately, all these things are models, just models, with all the limitations and all the issues that actuaries are quite familiar with. And so I feel that this AI revolution is a niche where actuaries can actually add a lot of value, if not as practitioners, but as advisors. So what is deep learning? We have essentially got this network of neurons. It's each of these neurons is quite similar to a GLM. You've got a linear set of weights that go in that create an output, and is transformed by an activation function, which if you were to follow the GLM analogy, would replace the link function. And this, on the right hand side, we've got a rectified linear unit, and that sounds really complicated, but it's just two lines. And with these two lines, if you mash them on a network of these neurons together, you can get nonlinear effects and something that is called a universal approximator, in the sense that it can approximate any kind of function that's transformed your inputs into an output. And so we've got an example diagram of a neural network here. Each of these neurons is connected to other neurons. They take in the inputs as a weighted sum of the weights, and then it then gets flowed through to the outputs. Now, one of the key features of deep learning models is their ability to extend to unstructured data. We've got convolutional neural networks, which work quite well on images. We've got embedding layers that can work quite well on text. We've got recurrent neural networks, long-term short memory, and gated recurrent units, which work well on sequences such as voice. We've got generative adversarial networks, which can create a very interesting loss function that can be used to generate unstructured data, such as images. And if you combine that with Monte Carlo tree search, which is what AlphaGo does, then you can plan for the future and strategize through this deep learning model structure. And that leads to a lot of flexibility in terms of what you can take in as both inputs or outputs of this model. And that's where a lot of the key power of these sorts of AI models comes from. But what we're really going to focus on today is the business side of things. As advisors, what should we consider when we see these business cases for AI in GI? And so I'll just present a few ideas for consideration. The first is, will the AI actually help serve customers better? AI can present opportunities to help us insure previously uninsurable risks, deliver services more efficiently, or potentially reach and protect more customers through new channels. But is that use case something that will actually help serve customers better? Is AI the right solution for the business problem that you're trying to solve? We've got a key use case of triaging customer inquiries. Do you need a natural language program or just a better business process? If you're answering common questions, do you want to do that via a chatbot, or would an FAQ on your website help serve your customers better? If you're working with missing data, then an AI model can help infer the missing data and fill in the gaps. But you can also just match on external databases, or perhaps even just ask the customer, even if it's a little less convenient. Is AI the right solution? And do the costs of this AI project outweigh the benefits? What are the opportunity costs of this project? Will it take resources away from more important priorities for the business? Is it possible to do a small trial so that you can work out the kinks and see if it really works before you commit, let's say, substantial resources to this project? Finally, are the expectations for your AI model realistic? A good guide, I feel, is this rule of thumb that Andrew has made quite popular. He's a Google Brain co-founder, Baidu chief scientist, and one of the co-founders of Coursera. His machine learning course is quite famous as a great introductory course. And what he said was that pretty much anything that a normal person can do in less than 1 second, we can now automate with AI. But the flip side of that is, in my opinion, is that if it is a complex problem that requires substantial human intelligence, that may not be a great use case for AI. So we'll go through some of the potential use cases within general insurance very shortly. In the first set, we'll talk about the AI GI Actuary. Can we automate the general insurance actuary functions with AI? And so we'll talk a bit about reserving, we'll talk a bit about pricing, and we'll talk a bit about portfolio management. So first up is claims reserving, and our evaluation of this is that there is a moderate benefits potential, and from a technical perspective, we're moderately ready for this as an industry. So in terms of the how, what you would do is we know that triangles models can be done using GLMs. So we also know that AI has a lot of plug-in replacements for GLMs. And so the very straightforward answer to this would be you could take those GLM-based reserving approaches and add regularization, replace GLMs with decision trees, deep learning, or some other AI GLM replacement. Alternatively, you can take a more time series-based approach and use gated recurrent units. Now, the advantage of that is that you can automate and take a more objective approach to your claims reserving. It's possible to essentially drill down to a more detailed level and potentially automatically identify anomalies via the decision trees or some other anomaly detection AI model. And in some cases, you can put together live results where your data just flows in through your warehouse and your model will automatically just refit and present results live. But there's a number of challenges with this. The first would be management headspace. If you're presenting daily claims reserving results, that may miss the opportunity to have a constructive conversation about it monthly. You also have an issue with potentially transparency, where these results may be more opaque compared to simpler approaches. And finally, the prudential requirements requires some degree of actuarial judgment in setting reserves. So there's no getting away from having that actuarial oversight. You don't necessarily have a lower amount of resourcing required just because you've automated your reserving models, because ultimately you still need to validate a lot of those more complex results. With pricing, from a technical readiness perspective, we're already there. Pricing is already quite heavily algorithm driven. There's a lot of exciting work already being done using gradient boosting in pricing, and the benefits are significant. There's definitely a business case there, but in terms of going further with deep learning compared to the level of detail that we're already doing with generalized linear models and gradient boosting, what's there today, that might be more of a moderate in my view. So the advantages is that you may want to maximize predictiveness. That has financial value because you're selecting better risks. Having machine learning allows you to react rapidly to demand, and the technology is already there. The key challenges would be around human oversight, though. What if something goes wrong? Could your prices in market without adequate oversight, the prices in market could lead to a lot of the wrong business being written without human intervention. And the other challenge would be linking in human judgment within that more complex structure. If you want to take in underwriting judgment, particularly within commercial lines where that's quite important, the heavily algorithm-driven approach may be more challenging in terms of incorporating that underwriting judgment in. Next, we have portfolio management, where there is some benefit, and a lot of the stats are already there. Machine learning and AI can help you understand your exposures better. It can help you identify clusters and segment your customers, and it can help detect changes in trend via machine learning analysis. That can be a great help in driving business decisions using data analytics. And ultimately, what we call traditional portfolio management, I feel, would be likely to shift towards more of a data analytics driven approach. But the challenge for actuaries working in this space would be product and underwriting know-how. If you consider the traditional product manager or underwriting manager, they bring a wealth of experience in terms of understanding of underlying risk. And as actuaries working in that space, a key challenge would be our potential knowledge gaps in that area. Next up, we have the AI savvy GI Actuary. So this is now taking our expertise and taking AI skill sets and expanding it beyond the traditional actuarial scope. So there is some opportunities in underwriting, sales, customer service, and claims management, which we'll talk a bit about. The first is underwriting. Going back to Andrew Ng's 1 second rule, if you've got simple underwriting acceptance decisions, it's quite possible to automate with AI. So what you would do is you would just take the actual decisions made by humans, the associated data with that, and then apply AI models. And AI models can handle unstructured data, such as natural language models. So if you've got brokers putting in descriptions that need to be validated by underwriters, that can be validated using a natural language model. And if you've got photographic information being passed through, you could potentially put that into a convolutional neural network and tag that image as to what the ultimate decision is. And there's a key advantage there for customers because instead of having a bit of a lag going through the underwriting team, you could potentially offer instant turnaround. And obviously there's a bit of an automation and efficiency benefit there. Key challenges: were the right decisions made in training data? If your existing underwriting team has gaps in their knowledge, then you could end up taking a poor decision-making process and automating that with AI. And handling new situations will be a key challenge. The AI models have a tendency to not recognize when it's outside of this competency, and that could lead to the wrong decisions being made. And finally, if you automate the system sufficiently, it opens it up for people to try to game the system. Whereas with human underwritten transactions, you may find that they're less likely to be gamed because humans will see through that. In sales, we've got some key potential insights in terms of triaging sales opportunities, particularly in B2B, by identifying the drivers of sales, success, or customer satisfaction. Through AI models, we can use that to grow revenue, make and drive that business acumen through data. And in terms of technical readiness, there's a lot of commercial products available, and that can already drive some of those decisions already. But key challenges, you may find that an excessive reliance on KPIs can be bad for your sales team culture. We've seen a few examples in the media of where there's an excessive drive towards KPIs, and that's led to short-term decision-making, or what IT folk call dark patterns, which is when you openly try to manipulate your customers to a certain outcome, and that may lead to a positive sales result for a given transaction. But over time, customers see through it and they start to distrust your brand. It may drive short-term benefit at the long-term cost of your brand image. And in customer service, the benefits potential is red hot. We've seen Google Duplex, where the Google Assistant was able to make a voice call to a restaurant or hairdresser and make a booking on behalf of the user, and mimicking human voice, complete with the ums and ahs of human chat. So in terms of the benefit here, we could have a future where the customer service team is always available. You don't have to hold for like half an hour just to talk to someone, except that someone is now a robot. You get a bit more consistency in service levels. You'll get a customer service representative that's always polite to you. And for businesses, there is definitely that huge automation cost saving there. And the technology behind that would be natural language models, perhaps linked with expert systems, or simple text matching to validate that, and like voice processing AI technology. But the key challenge there is that it's very much a nascent technology. Natural language is not quite there because although for simple categorization problems, it's been quite successful at categorizing sentences in terms of what they describe, wider conversations with contexts that can be quite often outside the box, it struggles to get the requisite level of accuracy at the present time. But technology is improving rapidly, and so this could very quickly become a key change in how insurers do business going forward. In the claims management space, we can see some key opportunities there as actuaries get more technical with things like their pricing or reserving models. There's a lot of insights about the types of risks that customers face and the claims process that could be then extended to the whole claims management business process. So in terms of case estimation, we've got Ping An having the ability to evaluate your motor accident by taking photos of it on your smartphone. It could potentially be used to triage simple versus complex claims via claims descriptions or once again, imagery. AI can help support supplier negotiations where the repairer gives you a quote, you go, yep, that's a good quote, or no, I'm going to go get a few more. And in terms of advantages, that can lead to, once again, a fast turnaround for customers who can get a bit more certainty and automate the process for greater efficiency. In terms of challenges, we know that customers, at the time of claim, they're often at a point of emotional vulnerability. And so dealing with an AI instead of a human being, some may prefer to have that human touch. And secondly, once again, if you open it up to a lot of automation, then there is that possibility for fraud. The fraudsters are always aiming to game the system, and if they can find a particular vulnerability in your automated claims management model, then they'll exploit that to the fullest. And so how do you identify and clamp that down very quickly? Finally, we'd like to spare a few minutes to talk about the non-AI GI Actuary in the AI-driven world. Even if you work in traditional general insurance space and you're not looking to change your processes at all, we see some new risks, and we see some potential fraud risks that may emerge using AI. So the first is your customers will be living in an increasingly AI world. So we've got here, my AI car got hacked. Am I covered? Does your products, will your products cover customers who are now operating in an AI enabled way? One key issue is around cyber risk. Although business executives globally see a lot of concern around cyber risk in the top 5 risks, only 33% have cyber insurance, and penetration in Australia is a bit better at 48%. But I still see that cyber insurance market is still quite in its early stages, and so you have to ask the question: are businesses adequately protected against the cyber risk? And another emerging risk is around fraud using AI. We are entering an era in which our enemies can make anyone say anything at any point in time. And so here we've got a still from a video of Obama saying those words, but actually it's not Obama saying those words, it's an actor called Jordan Peele, and the video is fake. The whole thing was produced using generative adversarial networks. The ability to Photoshop things is just getting ever more sophisticated, and are insurers prepared for falsified video evidence or falsified photographic evidence? And finally, we'll talk a bit about meeting community expectations. The first is around private and sensitive data. It's ever more important, especially when we go towards big data AI paradigms, to take adequate precautions to prevent the exfiltration of data or model intellectual property. Quite often, a lot of technology is going towards on-device models. So on your smartphone, you'll be able to take a photo of your, say, accident, and it makes a lot of sense from a technology perspective to have the neural network do all the image recognition on your device and give you a response right away. And that's great in terms of customer outcomes, but it also means that your model is on the device, which means that the bad actors can potentially extract it from your app. What sort of protections have you got for your IP there? Another thing is that natural language models can potentially leak training data. There's been a few papers that have highlighted the possibility of if you're training your natural language models on an email database, that someone with access to the model could then extract sensitive information that was in that email database. And so best practice would be to cleanse that sensitive information from training data, and as a second line of defense, potentially implementing these differential privacy algorithms, which train models in a particular way that ensures that privacy is protected. Thinking further on consumer rights and expectations, the Recital 71 of the GDPR is a good guide for best practice in terms of meeting those expectations. The first is that we have a responsibility to maintain clean and accurate data to have made any given decision. If we've got AI being trained on data, we have this responsibility to make sure that it's not garbage in, garbage out. And in terms of the actual modeling process, we as actuaries with a good grounding in statistics have a role to play, ensuring that those models are based on appropriate mathematical or statistical procedures. When evaluating a business process, we need to make sure that our consumers have the right to an explanation for the decision. It's not just a brick wall. If it's a significant decision that would quite dramatically affect our customers' well-being, such as the denial of a major claim, we need to have this passed through human hands and have the existence of channels to challenge that decision. And finally, there needs to be a bit of an awareness of anti-discrimination protections. So insurers get a waiver from the Anti-Discrimination Act on the proviso that it's based on reasonable actuarial, statistical, or some other basis. And so if you're moving towards a more opaque AI model, we need to make sure that's protected. In terms of practical considerations for implementing the model, we'll talk a little bit about data, model, and operational. The first is around data quality and augmenting data. So as I mentioned before, data quality is a key risk. And so if you don't have enough training data, what can you do? The first would be to look at pre-trained models. We've got a list of pre-trained models here. For image recognition, there's ImageNet, there's the Google News Word2Vec model for natural language. We've got a few more natural language models from datasets from Wikipedia, Wikitest. For voice recognition, there's the Mozilla pre-trained Baidu deep speech model, which has 5,500 hours of conversations. With the size of these datasets, it makes a lot of sense to use them as a starting point compared to your internal datasets. The next is around shining light into these black box AI models. The first consideration would be your choice of model. You don't necessarily have to use deep learning. It might be what's in vogue right now, but you may actually find that you get good predictiveness over models that are a bit more transparent, such as decision trees or GLMs. And if you do decide to use a more black box model, there are still ways of identifying the drivers of results. Things such as feature importance, partial dependence plots, the LIME, locally interpretable model agnostic explanation, or decision tree on the AI model as an overlay could help understand why the AI is doing what it is. And that's quite important because it helps validate some of the data and the model process as well. Another approach to consider would be to maintain challenger models. So this would be to maintain multiple models, which can help diversity of views. We can ensemble them together, which can often lead to better performance. Alternatively, take the AI model as a challenger against a more transparent modeling approach. So you use your GLMs as your primary model, which maintains that transparency and that explainability, but you use your AI model as a benchmark for how much model predictiveness that you've lost by taking this more transparent approach. It's important to consider what the core competency of the model is going to be, and that's driven by your training data. If you were to take, say, an example from life insurance, there was an insurtech startup that was looking to do selfies as a way to do quotes for life insurance. And the question for you, though, is whether or not that will give you sufficient accuracy compared to your expectation. This selfie model is likely to be based on a similar ImageNet-based approach, which led to the result on the right, where some unfortunate person was categorized as a gorilla. And so if you're considering that as the basis for getting your life insurance, is that good enough? Is that diverse enough? Adversarial model risk. If you remove all your human touch points, it opens you up to fraud possibilities. Here we've got a doctored image of two skiers on a mountain, and it's been doctored to make some very small changes. To human eye, it looks like two humans on a ski slope, but to a state-of-the-art image recognition model, it's a dog at 91% accuracy. And so if you're using image recognition as your basis for paying claims, today we might have doctored images for skiers and the dogs. Tomorrow we may have doctored images for making your claim a $30,000 claim instead of a $500 claim. And if we're using the same modeling approaches that is considered to be state-of-the-art and best practice, that can also introduce systemic risk because we're using the same processes that everyone else is. And so the key question is, do we have adequate controls for money laundering and fraud? Closing remarks. So advances in AI has led to powerful techniques, and we've looked at a number of examples of how that may just completely transform how we do business as general insurers. But it's also important to note the limitations and weaknesses that these new approaches may bring as well, and make sure that we have the adequate controls and mitigations to make sure that it doesn't go horribly wrong. And as actuaries, we are well placed to advise on the future. We've got the understanding of the data, we've got understanding of risk and risk management. We have an understanding of statistics, which is very important for validating these modeling approaches. We've got the commercial acumen within general insurance, and we've got a keen awareness of the regulatory context in which these models need to operate. And so, you know what? The AI savvy GI Actuary will do just fine. Thank you.